So let's go back to the nature of geographic information and explore why real-world phenomena are explored in GIS the way they are. So remember, the goal with GIS is to take the real world and to simplify it and organize it so it can fit into an information system which can be analyzed, queried, and explored. We do this by deciding whether our real-world phenomena are shown as vector, points, lines, and polygons, or pixels, known as raster in GIS land. One way in which we decide how a real-world phenomena is stored is by evaluating whether it is abrupt or smooth, and continuous or discrete. So let's think about this further. Does the phenomena change abruptly across space, or is it smooth and gradually changing across space? For instance, average income measured by county might be abrupt. For instance, in Clackamas County near Portland, the median household income is $62,000 a year. While just next door in neighboring Wasco County to the east, the median household income is $42,000 a year. This number changes abruptly at the county border. And indeed, most variables that are defined by borders are abruptly changing. Now let's think about terrain. On the East Coast, where there are more rolling hills, we would say that this is a smoothly changing type of phenomena. But when thinking about the Oregon coast, for instance, the terrain is abruptly changing across space. We have huge cliffs where you go from, say, 200 feet above sea level to literally sea level. A human phenomena that is smoothly changing might be something like the density of buildings across space. In the center of a city, there's a lot of density, and slowly as you move from the city center to the suburbs to the country, the density goes down. Here in Oregon, with our urban growth boundaries, sometimes there is an abrupt change in density of buildings, for instance, within and outside of the boundary. We might have high density in the urban growth boundary, while just outside is very low density. Again, boundaries often give you an indication that you're talking about an abruptly changing phenomena. Now let's talk about the other axis of this diagram, discrete and continuous. Remember, here we're talking about the phenomena. Whatever is out there in the real world. Is the phenomena continuous across space, or is it discrete, aka it's just in a few places? Discrete phenomena aren't everywhere. Cities, for instance, are discrete. They're not everywhere. You're in a city, and then you leave the city. Buildings are discrete because you're in a building, and then you're outside the buildings. Epicenters of earthquakes are also discrete. Not everywhere has an epicenter for an earthquake. Continuous phenomena are continuous across space. For instance, things like terrain or elevation are continuous. There isn't a part of the globe where there isn't some measure of terrain elevation. Even if it's 0 or negative, aka below sea level, there's still a measure for it. So why is this important? Well, the nature of the phenomena, whether it's abrupt or smooth, continuous or discrete, helps us decide the best way to represent that type of phenomena in a GIS. Abrupt and discrete phenomena, for instance, are best as vectors. They aren't everywhere. Most of the time, these would be points, which have 0 dimensions, or lines, which have 1 dimension. Smooth and discrete phenomena are best represented as vector points, for instance. Continuous and abrupt phenomena, down here in the lower left-hand corner, are best as polygons with no gaps in between. Can you think of an instance of a continuous and abrupt phenomena? What about counties within the United States? Within the boundaries of the contiguous US, for instance, there isn't a spot in our country that isn't within a county. But the phenomena that these describe often changes abruptly when we move from one county to the next. Finally, smooth and continuous phenomena are often physical or natural phenomena. Things like precipitation or elevation are usually smoothly changing and continuous across space. Of course, we can think of examples where this falls apart, but for the most part, our globe isn't full of a bunch of cliffs, for instance. Here's a map of earthquake epicenters. I'd say this is mostly abrupt. There isn't an epicenter everywhere, and it's more discrete than continuous. Although when we look at this graphic from McEachran in 1992, this map kind of falls in between continuous and discrete. In comparison, here we have some more earthquake data, but instead of epicenters, this is a shake map. We can see that this is a more smoothly changing phenomena. It gradually goes from really bad just north of San Francisco to less bad, to less noticeable, to barely noticeable. I'd also say that within our area of interest, aka the area that the map represents and shows, this is a continuous phenomena. But I don't know that I would say that if this map were of the entire US. In that case, I might describe this as something in between continuous and discrete. It's not everywhere. There's not shaking all across the United States. There's only shaking in California and the West Coast. Finally, let's look at a map of population density. Here, this is continuous across our area of interest because we have a measurement by counties, and counties are continuous across the United States, but the phenomena is abruptly changing. High population density counties can be right next to counties with very low population density. Although there are areas within the United States that this transition is more gradual, aka it's smoother, like on the East Coast, generally we'd say that this is an abruptly changing phenomena because you could go from very high density to very low density. Just look at Salt Lake City.